Hey kids, welcome to section 1.5, Graphing Linear Inequalities. Today we're going to learn how to graph linear inequalities and how to apply linear inequalities. So we've been mostly focusing on equalities until now, but today we're going to talk about linear inequalities. So a linear inequality resembles a linear equality equation, but it has an inequality symbol in it. So we've got these less than or equal to's, greater than or equal to's, greater than's, less than's. In case you have forgotten, a greater than sign points to the right, greater than, and a less than symbol points to the left. Once you put an equality part to it, then it changes what type of line it is. So notice that a greater than symbol or a less than symbol, this thing called a boundary line is dashed, and a boundary line cuts the entire coordinate plane into two chunks. Kind of like when we were doing number lines, we had numbers and we put a circle and then we shaded which way. We were saying the right side or the left side. Well, now we're saying the top part or the bottom part. So if it's a greater than or a less than symbol, then we're going to draw this boundary line using a dash. If it's a greater than or equal to or less than or equal to, then we're going to use a solid line, just connect the dots like a normal line. We're also going to think about if we are shading above or if we are shading below. If it's greater than, you can think about this as above the line. If it's a less than symbol, you can think of this as below the line. It depends which way the graph is tilting as to what above or below will be. So let's take a look. You probably have done this before, but you might have forgotten. So first, graph the inequality. So negative x plus 2y greater than or equal to 4. So first thing you want to do, kids, is you want to get it into slope-intercept form so that we can graph it. So we need to add x to both sides. 2y greater than or equal to x plus 4. We need to divide everything by 2. That gives us y is greater than or equal to. Now you have x over 2. Think of it as 1x over 2. So then you can think of it as 1/2 x. And then you have 4 divided by 2, which is 2. So your graph that you need to draw is y is greater than or equal to 1/2 x plus 2. So you start at the y-intercept on the y-axis. So you're going to start at 2. And then you're going to move with your slope. So you're going to rise 1 and you're going to run 2. And then rise 1 and run 2. And you could keep rising 1 and running 2 until you run out of space. And if you feel like it, you can go the other way. So you can go down 1 and left 2. And you could keep doing this until you run out of space. Notice that it's a solid line, so that is how we connect them. It's a greater than or equal to. Now because it's greater than, you're going to shade above. So if this is your dash line, or this is your boundary line, above it is all of this. You just use your pencil to shade it in as exciting as you want. All right, if we look at letter B, 3x plus 1/2 y is less than 2. We need to get it into slope-intercept form. So we're going to subtract 3x to both sides. 1/2 y is less than negative 3x plus 2. We need to get rid of the 1/2, so let's multiply both sides by 2 over 1. So that gives us y is less than negative 6x plus 4. Because we're distributing this 2. So that means we're going to start at 4 on the y-axis. And my slope is negative 6, so that means I'm going to go down 6 and over 1. Down 6 and over 1. This is a very steep line. If I wanted to, I could also go up 6 and left 1. Now this is a less than symbol, so it's dashed. So you're going to take and dash. It's also less than, so we're shading below. So if you take a look at this line, below would be to the left. So we're going to shade all of this stuff in. Okay, let's do some more. Letter C, 2 minus y is less than x. So you need to get the y alone. Remember, we're trying to get y equals mx plus b. So minus 2 and minus 2. Negative y less than x minus 2. Now this negative y, there's really a negative 1 here, so we need to divide everything by negative 1. We are dividing by a negative, so that means our inequality flips direction to be a greater than. And then I have 1 divided by negative 1 is negative x, negative 1x. And then negative 2 divided by a negative 1 is a positive 2. There are lots of places to make this incorrect, so make sure you're dividing by negative so you flip the inequality. And then you're taking each of the things on top and dividing by negative 1. This means we start at 2. Our slope is negative 1 over 1. So you're going to go down 1 over 1, down 1 over 1. You could keep doing this as much as you wanted. You could also go up 1, left 1 if you wanted and continue that. But it's going to be a dashed line because there's no equality to it. And then go this way. It is greater than, so it is above. So if this is your line, above is here. All right, letter D, 9x minus 3y minus 6 less than or equal to 0. So we need to get the y alone. So let's minus 9x to both sides. So negative 3y minus 6 less than or equal to negative 9x. Let's add 6 to both sides. Negative 3y less than or equal to negative 9x plus 6. Divide both sides by negative 3. We're dividing by a negative, so we flip the inequality. We have negative 9 divided by negative 3, that's a positive 3x. And then we have 6 divided by negative 3, that's a minus 2. So we need to graph y is greater than or equal to 3x minus 2. So that means we're going to start at negative 2. The slope is 3 over 1. So up 3 over 1, up 3 over 1. You could keep going if you wanted. It is a solid line because it's equal to. It is a greater than, so it is above. So above would be on this side. You don't have to fill in every square, but I should be able to tell which way is which. All right, let's go the other way. I'm going to give you a picture, and you're going to tell me what the inequality is that represents it. So I want you to write me an inequality in slope-intercept form for the graph. All right, so in letter A, first thing you want to do is you want to figure out what the y-intercept is. That's the first thing you want to do. So look and see where the graph crosses the x-axis, and that would, or the y-axis, and that would be at negative 1. So it looks like your B is negative 1. Then your slope. Well, your slope is positive, so that's good. And then you want to find 2 points on your graph. So maybe right here at 0, negative 1, and right here at 1, 0. If you just count rise over run, you rise 1 and you run 1. So that means your slope is 1 over 1. So your slope is just positive 1. So now we can go y. Now don't put an equal sign here. Put your mx plus b, so 1x minus 1. And now the symbol that you're going to put there, notice that the graph is below, so that's a less than. It's a dashed line, so there's no equal to. So we got y is less than x minus 1. All right, if we go to letter B, first thing we want to find is the y-intercept. Where does it cross the y-axis? It crosses it at 2, so our B value is 2. Our M, if we notice, our slope is going down, so our slope is negative, and so you want to pick some nice points. I got 0, 2, and let's see, maybe down here at 3, negative 5. So that goes down 1, 2, 2, 3, 4, 5, 6, 7. -7, and run is 1, 2, 3. So the slope is -7/3. Sometimes your slope is a fraction. It's not always pretty. So now we got y. Let's leave a space. Let's do mx plus b, so -7/3 x plus 2. Notice that it is shading above the line, so that's a greater than. Notice it's a solid line, so that's an equal to. So y is greater than greater than or equal to -7/3 x plus 2. All right, if you look at letter C, notice that we have a vertical line here. Vertical lines are nice because it's just x and the number, and then we put an inequality inside. So it's going through the x-axis, so we're going to put an x here. We can't do it the way we did it before. Notice it doesn't even cross the y-axis, so there can't even be a b. And then you want to see where it crosses. It crosses it at -4, so we're going to put a -4. Now the above and the below doesn't work quite the same way. Above is to the right, and below is to the left. So since we are shading right, that's kind of like above, and above is greater than. Notice it's a solid line, so equal to. X is greater than or equal to -4. If you look at letter D, this time it's going through the y-axis, so we have a y here. It's going through the y-axis at 4, so we have a 4 here. It is above, so it's a greater than, and it's a dash, so there's no equal to. Y is greater than 4. Okay, let's apply this linear inequality idea to word problems and something called constraints. So a constraint is a condition that the solution of a problem must satisfy. For instance, if you're trying to find the speed that your car travels as a rate of change, your car is never going to have a negative speed. Even if you're driving backwards, that speed will still be positive. You can't have negative time, you can't have negative speed. So the constraints are that stuff must be positive. And you can think of these constraints them as a limitation or a restriction. If the distance someone is jumping is at most 12, then you're never going to have a value bigger than 12. Let's talk about an application of a word problem to a linear inequality. So Manuel has $25 to spend at the county fair. The fair costs $7.50 for admission, $1.25 for each ride ticket, and $1 for each game ticket. Write an inequality to represent the number of rides R and G game tickets that Manuel can buy, and graph the inequality. Notice that I only gave you quadrant 1 to graph. That's because you can't have anything negative. You can't have negative rides that you rode. You can't have negative games that you played. It's positive, so it's only quadrant 1. Also, notice you have G's and you have R's, no X's and Y's. So you get to decide if you think that the rides should be X or should the rides be Y. It doesn't matter. I'm going to make the rides be like my X and the games be like my Y. So I'm going to put an R over here on the X-axis, and I'm going to put a G on the Y-axis just to keep my mind straight of which letter is which. Now I need to come up with an equation. It's $7.50 no matter what to get into the fair, so I'm going to put $7.50 plus. Then I got to pay $1.25 for each ride, and the ride is R, so I'm going to put 1.25 R. Then I also have to pay for games. They're $1 for each game, and game is G, so I'm going to put 1 G. And I only have $25 to spend, which means I can only spend less than or equal to $25. Now, in order to graph this inequality, I need to solve for y, but there is no y to solve for. I can solve for g. So I'm going to solve for g, and this is going to help me graph it. So let's subtract 750 from both sides. That gives me 1.25 r plus g is less than or equal to 1750. And then if I minus the 1.25 r to both sides, I get G is less than or equal to negative 1.25R plus 1750. This is what I'm going to use to graph. So I need to go over here and I need to graph. Well, R stands for the number of rides, and that's whole numbers. I don't know, maybe we count by one. So this is rides down here, and let's see, 1, 2, 3, 4, there's 5, and then 1, 2, 3, 4, there's 10. 1, 2, 3, 4, there's 15. Kids, they go by 20, so that's 20 at the end. This is 0. Vertically, well, I need to get to 1750. Now I don't want to count by all those decimals, so let's just count by ones again. This is going to be your games, so let's count by ones again. So 1, 2, 3, 4, there's 5. This goes to 20 as well. 2, 3, 4, there's 10, there's 15, and then you got 20 up at the top. All right, so we need to start at 1750. So 15, 16, 1750 is going to be right there. Now, negative 1.25 as a slope is kind of weird. So you can think of negative 1.25 as negative 5/4. It makes it a lot easier. So that means you're going to go down 5 and you're going to go over 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4, put it up. 1, 2, 3, 4, 5, 1, 2, 3, 4, put it up. 1, 2, 3, 4, 5, 1, 2, 3, 4, put it up. Now this isn't equal to, so we're going to connect them. Here's the thing, kids. You're not going to put arrows because the graph is only in quadrant 1. So you don't want to use any arrows whatsoever because it's not going to go out of quadrant 1. All right, we also need to shade because it is an inequality. The less than symbol means to shade below. So if you're looking at this graph, below is underneath. So it's basically all of this in here. Sometimes you do shade the outside and sometimes you shade the inside. So it's just whatever the problem is. Letter B, does Manuel have enough money to purchase 6 of each type of ticket? Explain your reasoning. Well, you have 2 choices. You can think in terms of your picture, and so if you find 6, 6, it's kind of right. Let's see, let's change the color so that you can obviously see it. Let's do pink. 6, 6 would be right there. So notice that 6, 6 is in the shaded region. That means that that's an okay value, and so that's going to be yes. It's in the shaded region. Looks like I chose purple. Oh well. Now, if you don't like that explanation, what you can do is you can substitute 6 in for X and 6 in for Y, and you can see if you get a true statement. So 6 in for R and 6 in for G. So 6 is less than or equal to negative 1.25 times 6 plus 1750. If I do that, I get 6 is less than or equal to 10. That is a true statement. So the answer is yes. If I had gotten, say, 6 was greater than or equal to 10, then I would have said no. Okay, let's do one more example like this. A recreation center offers various 30-minute and 60-minute art classes. The recreation director has allotted up to 20 hours per week for art class. Part A, write in inequality to represent the number of classes that can be offered per week and graph the inequality. Okay, well this one doesn't give you any letters, so you get to choose. I'm going to let X be the 30-minute classes and Y be the 60-minute classes. So I'm going to label over here X and Y. Now the other thing that you should notice is that the total is given in hours, but the variables are given in minutes. So I either need to change everything to minutes or I need to change everything to hours. Let's change everything to hours. It'll make it a lot easier. So if I have 30-minute classes, that's a half an hour, X. Plus, if I add 60-minute art classes, that's an hour apiece, Y. And I have up to 20 hours a week for classes, so less than or equal to 20. 1/2 X plus 1Y is less than or equal to 20. Solve for Y because that is the variable that we put on the vertical, which means subtract 1/2 X. So Y is less than or equal to negative 1/2 X plus 20. So now I can graph this. Well, I need to get up to 20 for my y-intercept. So maybe I count by 5 or count by ones again. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's 20 up here. 15, that's right there, and that's 10, and that's 5. And then if you go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 20. Okay, and these are 30-minute classes. It's always important to label your axes. And these are 60-minute classes. Okay, so we need to start at 20. That's our y-intercept up here. And then my slope is negative 1/2. Since I've counted both axes by the same amount, then I can go negative 1, right 2, down 1, right 2, down 1, right 2. So this is, keep going. This is less than or equal to. So it's a solid line. So if I keep going, oh, that is horrible. Hold on, let me fix that. Okay. I need a less than or equal to, which is a below. So I'm going to, oh, and I shouldn't have had an arrow, but it is going to go down more out of the picture. So less than or equal to is all of this. Can the recreation director schedule 25 of the 30-minute classes and 15 of the 60-minute classes during a given week? Explain your reasoning. Okay, well, if I have 25 of the 30 minutes, that's 25 down here, and 15 of the 60 minutes, it looks like it's going to end up somewhere outside. Well, to verify, let's plug it in. Let's plug the 25 in for X, and let's plug the 15 in for Y, and let's see if we get a true statement. So 15 is less than or equal to negative 1/2 times 25 plus 20. That's 15 is less than or equal to negative, oh, I didn't calculate this. Oh, negative 12.5 plus 20 is 7.5. Is that a true statement? And the answer is no, that is not a true statement. So no, he cannot do 25 and 15. All right, kids, that is the end of section 1.5. If you have any questions, please let me know. And as always, keep calm and keep trucking.